Today we're diving into the universe's ultimate recipe book. And no, I'm not talking about baking a cake. We're talking about the insane chemical reactions that can launch a rocket straight into space, and how scientists get that recipe just right every single time.
You see this incredible display of power? You know what that all boils down to? A perfectly measured, perfectly executed recipe. The solid fuel in these things is this super precise mix of chemicals. If the proportions are off by even a tiny bit, the whole mission's a bust. But when you get that recipe just right, you can literally reach for the stars.
So how in the world do they pull it off? How do scientists write a recipe so precise it can control that kind of raw power? And how do they know exactly how much of each ingredient to toss in to get the perfect amount of oomph? Well, the secret is a universal language used by chemists all over the globe. It's not written in some dusty old cookbook, but in the elegant shorthand of the chemical equation.
Okay, so every recipe needs ingredients, right? In chemistry, we call them reactants. They're the things you start with, the stuff that's going to change. You'll always find them on the left side of the reaction arrow.
And what about the result of your recipe? We call those the products. That's your finished dish, the brand new substances that get created by the reaction. And you'll always find those on the right side of the arrow. Simple, right? Ingredients on the left, final dish on the right.
Put all that together and voila, you've got yourself a chemical equation. It's the whole recipe in one line, showing what you start with and what you end up with. But here's the thing, just listing the ingredients isn't enough. For a perfect result, the amounts have to be spot on. And this is where we hit a fundamental law of the universe. You can't just create or destroy matter out of thin air. In a chemical reaction, atoms are they're just rearranged, they're shuffled around. That means your recipe has to be balanced. Every single atom you start with has to be accounted for in the end, no exceptions. So, how do we get that balance? Look at the top equation here. It's unbalanced. The atom counts on each side just don't match up. The fix? We add these little numbers out in front of the molecules. We call them coefficients, and they're what makes sure the atoms on both sides of the equation are totally equal, satisfying that law of conservation.
So what are these coefficients, really? Just think of them as the measurements in our recipe. They tell you the precise ratio you need, kind of like saying you need 2 cups of flour for every 1 cup of sugar. They are the absolute key to getting your proportions perfect.
Now, the whole science of using these balanced recipes to make super precise calculations, well, it's got a pretty fancy name, stoichiometry. Yeah, it sounds a little intimidating, I know, but it's really just the math behind our chemical recipe.
At its heart, stoichiometry is just the study of the relationships between all the different amounts of stuff in a reaction. It's the how-to guide that lets us use our balanced recipe to predict exactly how much product we're going to make or how much of an ingredient we're going to need. And the secret weapon for doing all these calculations is something called the stoichiometric factor. It's like this magic conversion tool that lets us jump between any 2 ingredients or products in our entire recipe.
So what is this all-powerful factor? You're gonna love this. It's just the ratio of the coefficients from our balanced equation. That's it. It's our recipe's golden ratio, and it lets us calculate exactly how much of anything we'll need or produce.
So let's just boil this all down, okay? The whole process is really a simple 3-step dance. Step 1, make sure your recipe, your equation, is balanced. Step 2, use those coefficients to find the right ratio, your stoichiometric factor. And step 3, use that ratio to calculate your amounts. That's it. That is the core of stoichiometry right there. Of course, you know how it is. A perfect recipe on paper doesn't always guarantee a perfect dish in the kitchen. In the real world, when we move from the blackboard to the actual lab, things can get, a little messy. And this brings up 2 really key ideas. First, you've got your theoretical yield. That's the absolute max amount of product you should get according to your perfect recipe. But then there's the actual yield. That's the amount you actually end up with when the experiment is all said and done. And yeah, in the real world, the actual yield is almost always a bit less than the theoretical one. Why? Oh, lots of reasons. Maybe the reaction didn't go all the way to completion, or maybe you lost a little bit of product while you were collecting it. It's like spilling some batter on the counter when you're baking. It just happens. So to figure out how successful their reaction actually was, chemists used this super simple formula for percent yield. It's all about efficiency. Are you getting 90% of what you expected, or is it more like 50%?
For chemists in research and industry, that number is absolutely critical. So why does all this talk of recipes and ratios and yields actually matter? Well, because these principles are literally the foundation for so much of our modern world. And the applications go way beyond just launching rockets into space.
I mean, these are the skills that allow scientists to analyze stuff with incredible precision. They can figure out exactly what elements a new material is made of, or measure the exact concentration of a chemical in a solution, like testing a water sample to see if it's pure.
When you get right down to it, stoichiometry is how we answer two of the most basic questions in chemistry. What is this stuff made of, and how much of each part is in there? The answers to those questions are vital for everything, from developing new medicines and foods to manufacturing the tech we use every single day. From the fuel burning in a rocket to the complex molecules working inside our own bodies, chemical reactions are the recipes that literally build our entire world. And understanding how to read them, balance them, and use them, that's basically a superpower. So the only question left is, what recipe will you discover?